to write 1 over 4 to the 11, or do I write 4 to the minus 11? And they're all correct. It really does depend on whether, with the lesser of two evils between these two, are you trying to avoid negative indices, or are you trying to avoid fractions? You can always do either one or the other, always. Okay, so fractions become a novelty or a luxury that you don't have to have once you have negative indices. And you'll certainly see that as we push on. So now we have the number minus a sixth. So what you should immediately be thinking is that minus does nothing. It gets cancelled straight away because of the square. So we're not going to talk about the minus anymore. So what I will say is that is, now after a while you're going to start going straight into this and say I'm finished. Okay, but I'm afraid that might leave somebody behind. So I'm going to say it's 1 to the power of 6 to the power of 5, and then I'll drop the 5 downstairs. And while I'm at it, I'll say it's also 6 to the minus 5. Take your pick. And honestly, the back of the book could say either. It really depends. You see, write it in index notation, but write what? It didn't say write it as an integer in index notation, so it's really not clear. And you could say either one is correct. The 0.2, I think really what we're 0.2 in an expression, we really want to call that a fifth. Okay, the minute you put 0.2 in your calculator, it's going to say it's a fifth. So you want to be going, that's a fifth cubed times a fifth squared, which is a fifth to the power of 5, which is equal to 1 over 5 to the 5, or 5 to the minus 5. Again, take your pick. Now 2.4, got your calculator. Remember, I'm in table mode here, so I'm going to bring her back, back to computation mode. I'm going to key in 2.4 and say, what the hell, what is it as a fraction? Well, it's 12 over 5, great. So that way, you see, you like that way more. It's much better for calculations, 12 over 5. So I got 12 over 5 to the 5 times 12 over 5 to the 8. Well, that's 12 to the 13 over 5 to the 13. Now here's where I'm saying you can kind of always avoid a fraction. You could call that 12 to the 13, 5 to the minus 13. And it's 6-1, you'll be second guessing what way do they want in the exam. Of course, the best thing to do is to write down both. The examiner comes along and says, that's the marking scheme says that's correct, and you get full marks, or this is what the marking scheme and that's correct, and you get full marks. So you got to take your pick. Okay, so we've negative 2.7, which is going to be, I suppose already know. So basically you're saying let's just write it as negative 2.7 for a second. I'll be dividing by 10 in a second. I'll be using a tenth. But it's negative 2.7 all to the power of 7. Now it's a negative to an odd power. So we know conceptually that that's just the negative of 2.7 itself to the power of 7. Now that is 27 over 10 to the power of 7. And you've 27 to the power of 7 over 10 to the power of 7. And you've 27 to the power of 7 times 10 to the minus 7. And as I say, trying to guess what they're going to say in the marking scheme is there's no need. Just write down every possible answer and you're good to go. Okay? And we're on to 3.2. Negative 3.2 to the power of 10 times negative 3.2 to the power of 5. Different ways to treat this. You can just say it's negative 3.2 all inside still. You see it's cocooned inside to the power of 15. Now it's negative to an odd power, so it's negative. It's negative 3.2 all to the 15. Now notice how different this is. The minus has come out. It's come out because this was odd. If this was even, it would have just evaporated. It either evaporates for even or it comes out for odd. Okay, now that's 32 over 10 but to the power of 15. And of course this is actually, what's half of 13? 16 over 5 to the power of 15, and then you're writing it like this. And then you're going one step further, maybe in what way, as I say, I'm gonna get tired now of saying that you're second guessing what they're going to say in the back of the book. But that's certainly in index form. It's 16 to the 15 times 5 to the minus 15. That's what the back of the book should say, and it probably does say that. Okay. I'm making a very long video just to cover the entire section, and you can go through it. So I have 6 on, yeah, it's quite a long homework actually. You're going to need this video possibly to help you with it. So we have 3 to the 7 over 3 to the 6 equals 3. Okay, because it's 7 take 6 is 1, but you don't have to write 3 to the 1. 7 to the 12 over 7 to the 5. Let's work straight down. Next answer, 2 to the 6, 9 take 3 is 6. Okay. Next answer, 10 to the 5 over 10 to the 2 is 10 to the 3. 5 take away 2 is 3. 12 take away 5 is 7. So you get next answer up here is 7 to the 7. Now ignore the minus 12 for a second. 9 take away 4 is 5. So we'd minus 12 to the 5, but that's minus 12 to the 5. Okay? 6 take 3 is 3, and it's a negative, so it's going to be negative 2 to the 3. The negative survives, if you like. Okay, 4 to the 1 over 4 to the 1 equals 4 to the 0. Do you leave it like that? You could. You leave it like that. That's an index form. Of course, that's not an index form. That is an index form, but you're going to annoy people, so you just leave it like that. It's 4 to the 0. That's another way of saying 1. Now we got negative a half to the power of 4, which is 1 over 2 to the power of 4. Now that might kill you. There might be a lot going on there. Right, what's 17? Take 13. So 17 take 13 is 4. Negative to an even power, the negative evaporates. So that's a half all to the power of 4. But this is a unit fraction. So the 1 to the power of 4 is pointless. It doesn't necessary. See, that's to the power of 4 and this is to the power of 4. Okay, so you get 1 over 2 to the 4, or you get 2 to the minus 4. Okay. Now overall, we have minus 3 fifths in a bracket to the 3 over minus 3 fifths in a bracket to the 10, which is minus 3 fifths all to the power of minus 7. Now, the negative survives. It doesn't matter if this is minus 7 or plus 7, it's odd. So this is now minus 3 fifths itself to the power of negative 7. Now, it's the same as 5/3 to the power of 7, because it's 3 to the minus 7 over 5 to the minus 7 with a minus in front of it. But 3 to the minus, ignore the 3 to this 5 to the minus 7. This 3 to the minus 7 can go downstairs and change sign. And this 5 to the minus 7 can go upstairs and the index changes sign. And that doesn't change at all the fact that there's a minus out here. So our final, so we get minus 5/7 over 3 to the power of 7, 5 to the power of 7 over 3 to the 7. But that could be called minus 5 to the 7 times 3 to the minus 7. You got to take your pick. Or best off, as I say, keep writing them all out. Okay, so that's 6 finished. And granted, I'm working at a fair old clip. Now we're talking about a power of a power. So, and I'll just try and show you the question on the left hand side, and I'll just go straight to the answer when I can. So 3 to the 15 will be that one. 7 to the 42 will be this one. 2 to the 4 will be this one. Okay, we see this? 6 to the 4 to the 5. 4 5s, 20. 6 to the 20, that's your answer. 8 to the 15. 13, 3 9s, 27. 10 to the 25. 16, 2 3s is 6. 4 to the 30. And 10 to the 36, 4 9s is 36. So now we're getting into mixed rules as we go into question 8. Okay, mixed rules. So I'll do the top. 3 5s is 15. The bottom stays alone. And then that's 8 to the 13. Okay, down below, 3 6s is 18. Sorry, up above, and down below as in down below there. And then we've got this is 7. Now be careful here, and I did it, didn't I? I got mixed up. How did that happen? Did I do that in the previous one as well? I did, because I've just come, and that's enlightening. I've just come from using the power of a power rule, and I totally made a mess of it and got into that groove. Okay, a human error on my part, and very revealing human error. So we go back and we start this again. Question 8, part 1. So I actually should have just added 3 and 5 is 8 at the top, giving me 8 to the 6. Okay, I should add the 3 and the 6 to 9, add the 4 and the 2 to 6, and now subtract, and we get 7 cubed. 9 take 6 is 3. Now we're over here. Oh no, they're really having fun now. So this is worth 8. This is worth 1. Top is worth 9. Okay, 2 to the 2 4s is 8, and 1 here, and then you have 5 to the 1, which is a sneaky one. All over 5 to the 3 equals 5 to the 6. Okay, 6 cubed by 6 to the 30 over 6 to the 11. I'll just add them already straight away. Okay, that's 6 to the 33 over 6 to the 11, which is 6 to the 22. Crazy stuff. Now you wouldn't get a whole bunch of these like in the Leaving Cert exam, but you do need to use them from time to time. And we're into question 9 now. We got 3 to the 11 over 3 to the 4 equals 3. And get your subtraction, be very careful with your subtraction, and that's 3 to the 7. Okay, 5 and 6, and not times. And of course this times, it's almost killing us there. Like it's very tempting to multiply the 5 and the 6, but it's not. We're adding them. We're adding them, and we're adding the 3 and the 2 underneath. And of course, understanding the rules is one thing, but going and actually applying the rules is a different thing altogether. So you're at a different level of learning and performance here. 11 take 5, I think, is 6. It is 6, so that's the answer there. Okay. And come on, we're nearly finished now. Just keep going, just another little bit. 5 to the 21, 12. Did I get that right? 12 and 9 is 21. Over, now this is a power, so it's not 5, it's 5 to the 6. And that's 5 to the, what's 21 take 6 is 15. And we're done. And now they seem to be really taking the gloves off for the last one. And the thing to do when that happens is to slow down a bit. 5 to the 6 times 5 to the 6 divided by, now what I can do with that divided by is I can draw a line and I can say, well, I can put it downstairs. I can put it to the left or to right, it doesn't matter. So I'm putting it downstairs and I'm processing that as to 8. Okay, I'm adding them is 11. I'm adding them, it's 12. The answer is 5. But if they wanted an index form, then you have to go and say it's 5 to the 1. Because it's not an index form if you just say 5. Okay, and we're moving on. I think we might want to go back and spend some time on Tuesday on these as well. But that's a nice little YouTube video, albeit very long, to get you through them. Okay, pause often, slow me down, and we'll try to get back to more traditional going through the book page by page I've had some feedback that GeoGebra, and I agree fully that GeoGebra has really been making a mess of the classes. OneNote can be used, okay, as long as we just. But having said that, I think paper and pen, or even using the whiteboard behind me here, might be the way to go and keep it traditional. Because after all, real exams are traditional. See you tomorrow. Bye bye.